And with all of that preamble aside now, I am very pleased to welcome my good friend and longtime colleague, Addison Snell. He is the co-founder and chief executive officer of Intersect360 Research. He is one of the leading analysts for tracking the HPC and AI infrastructure markets. He is particularly effective at tracking the influence of hyperscalers in these markets, and that is exactly what we're going to talk about today. Welcome, Addison.
Hey, thanks very much, Jay. It's great to be back in the Google Cloud Advanced Computing community. This is a great community effort that you've built, and I'm delighted to participate. Thank you.
Well, we're excited to have you. I'm going to go off camera while you present your slides, and then I'll come back on for our conversation and then for Q&A from our audience as well.
All right, well, thanks, Jay. And I'm not going to present for very long. I'm really looking forward to having a back and forth with you on this, because debating with Jay Boisseau is one of my favorite ways of learning about the influence of HPC and AI and hyperscale. As analysts, we have to have perspective, sure, but we get that by speaking with other experts around the industry, in the end user community, in the vendor community, among policymakers, and I'll talk about one of our own community efforts toward the end of the presentation. But it's really in these conversations, like we have in this Google Cloud Advanced Computing community, that I learn as an analyst and start moving things forward. I was asked to talk about hyperscale and its effect on the HPC and AI markets, and I'm going to draw from an article that I published recently in HPC Wire called 5 Big Questions for HPC AI in 2025. It'd be easy to search and find it, although I put an embedded QR code that I generated in Google Chrome on there. So, and keep your cameras handy. There will be a few more of these on my slides as we keep going. How big so I had five big questions facing the market, including how big can the AI market get, but pertinent to this particular talk is, will hyperscale computing completely take over enterprise? And we have a discourse in that article about some of our data that points to the really dramatic rise in hyperscale. I'm not going to be able to go through all of these things here today, but I have presented on this at the Rice Energy HPC conference, and this will be a theme that we'll keep touching on at Intersect360 Research over the course of 2025, looking back at these big questions and talking about how they influence the market. This is our most recent revised HPC AI infrastructure forecast from late last year. Now, this is not updated yet for year-end 2024. Officially, 2024 here is still a forecast, not actual. Now, you'll say, hey, it's April 1st. Get with it. Why haven't you wrapped up 2024 yet? All the vendors haven't even finished reporting on 2024 yet. So it usually takes until late April, early May for us to finalize the previous year and come out with a new 5-year forecast. So it's kind of an awkward time of year for me to present on something like this. But since this was revised in October, just prior to SC24, it should be pretty close on the infrastructure side for 2024. And what you're seeing is another really dramatic triple-digit growth year in infrastructure for hyperscale AI year over year. So what you're seeing is the segmentation in this chart is the darker blue at the bottom is what's effectively the non-hyperscale, not cloud, on-premises HPC and AI market, which is growing at what should be a pretty good clip. I mean, normally the amount that we increase that by would be the big story here, but the dramatic increase in hyperscale AI, and that includes cloud infrastructure that gets used by other non-hyperscale budgets, but where's the infrastructure for it? That's where 2024, we're seeing it 6x where it was in 2022. So when we talk about the hyperscale effect on HPC and AI, realize that AI is predominantly a hyperscale market. It started in hyperscale, the big growth is in hyperscale, and hyperscale in this context is a lot more than just cloud. It's, in fact, we tend to use the word hyperscale instead of cloud. I think to say this is the cloud portion of the market really undersells it. Cloud service provider is one line of business that a hyperscale company could be participating in. But when you look at the biggest ones, Google, Microsoft, Amazon, these companies are bigger than their cloud offerings. Amazon is a much, much bigger company than AWS. Microsoft is a much, much bigger company than Azure. Google is a way bigger company than Google Cloud. And when you look at the infrastructure that goes behind things like YouTube, right, that goes back into the same hyperscale infrastructure companies again. Microsoft and Office and their whole Office suite and chats and emails, everything that goes into that. Meta is another good example. I like this site. Meta is one of the largest hyperscale AI company investors and isn't a cloud company at all. But you look at the company that's behind, WhatsApp and Instagram and how much that Facebook is putting into this, it's really quite a lot. So it goes beyond cloud. Certainly, this does include what gets offered as clouds to other HPC and AI users. And we think this hyperscale AI segment will near $200 billion in 2028. Now, the on-prem is still growing, but it's nothing compared to what's going on with AI in the hyperscale side. We've published a few times this Venn diagram of where the on-prem spending is. We hear a lot about enterprise AI and how that's going to grow. Now, this is from last year's survey. This year's survey is still in progress. But when we surveyed large enterprise, regardless of it being an HPC or AI list, we just went out to, let's talk large enterprise and go survey them. We found that 95% had spending that was tabbed to either HPC or AI, or possibly both. And then when we did the breakdown on that, there was like a 10% on one side that was HPC only and no AI. There was another 10%, technically 11, that was on the other side that was AI only and no HPC. And the other roughly 80% in the middle had both. And then when we saw that they had both, we could look at, well, HPC and AI, are they together? Are they separate? Are they the same thing? Is it mostly HPC? Is it mostly AI? How much are they growing relative to one another? It's not all in one chart. How much is on-prem? How much is cloud? Right? What are the barriers? What are the growth factors? And we studied all of those things, and it informs our market size and forecast going forward. This is in progress again right now. I've seen most of the early responses. Well, beyond early, the survey is still open, but we're nearly finished. What's really going away is this HPC only portion. The AI only portion has grown very little. Really what you're seeing is that if you're doing HPC, you're also doing AI. You might be doing AI without HPC, but it's not super common. Mostly what we see is outside of hyperscale, most people are doing both. And that's where the influence of AI is dominating HPC budgets. And we hear a lot of people say, I can get AI spending, I can't get HPC spending. Now, another of my 5 big questions is what's going on. This is large enterprise. What's going on in public sector is going to be very different and looks different depending on what country you're talking about. The United States is particularly topsy-turvy right now with regard to public sector funding. And I think what we'll see, and one of my other big questions for HPC and AI, is a depression in public sector funding in the United States. And corresponding with that is an increase in private sector or commercial spending. And things will shift a little bit. Does it completely make up the gap? We still have a month to work that out. But I think you will see a significant effect of the current U.S. administration in how we measure the HPC and AI market. We do definitely look at the cloud penetration of HPC and AI. That went into really hyper growth mode starting in the late 2010s, around 2017, 2018. We got into a double-digit growth of of cloud penetration in HPC and AI. 2017, really 2016, I think was the first double-digit growth year, and then 2017, 2018, it really accelerated. A lot of that had to do with the maturation of software licensing models from ISVs that had been punitive toward variable spending in cloud, and then got less so. It was easier to bring these things forward into cloud. 2020, 2021 were super growth years in cloud, and that was directly because of the pandemic. One thing cloud does really well with is uncertainty. If you're uncertain about your budgets, if you're uncertain about your workloads, cloud with its variability, really there's a huge benefit to it, and people will pay a premium in order to get it. What we saw then was, according to our budget data, things were going to start to smooth out, and cloud was getting toward an asymptote where it was a stable part of the market that was growing along with the market. And that was the effect that we saw out toward 2027, 2028. I think that's really going to start to change again, and we'll see a big pickup in cloud again, related again to that other big question about effects in US administration. As I said, cloud does really well with uncertainty. So we're entering into a new era now where people are unsure what workloads they have going forward because of AI, because of data analytics. People are unsure about what architectures they want to map to that because of the rise of GPUs and different interconnect choices. What CPU do I want? And the more it's uncertain, the harder it is for someone to say, well, this is definitely the infrastructure that I want to run in my HPC AI lab over the next 4 to 5 years. If I'm certain about it and I know what capacity I need and I know what the mix is, then it can be really cost effective to buy it and push that out forward and say, this is what we're doing. The more variable it is, the more you want to start looking at, all right, do I need the variable spending that's in cloud? And we're even measuring that with regard to LLMs and what do people want to run internally versus externally. Prior to the last election cycle, people were starting to see more stability in what they wanted going forward. I think this new round of surveys coming in is showing us there's less stability there, and people might see a lot of value in that cloud side again, which would push more of the infrastructure back out to hyperscale. In the long term, and I make this point in this article, that can make it more difficult for the traditional server OEMs, your HPEs and Dells and Eviden and Fujitsu and whoever, for the traditional server OEMs to compete if they've got a reduced market and more is going over to cloud. We've already seen, if I break down the server portion of this into entry-level, mid-range, high-end supercomputer, that entry-level flattened out and in some cases goes negative in our forecast. And that's really the effect of cloud, because cloud displaces entry level and mid-range more than it does at the high-end and supercomputer side. That was the first time we ever saw any of these HPC segments go negative in a long-term forecast. And that had to do with the cloud pull away from entry level on premises. So we'll release that again coming up in a couple of weeks. Watch this space. We're pulling together the budget data and the supplier data now, and we'll have a new presentation on that prior to ISC. This is not a completely new phenomenon. We have been watching this for a long time. When we were founded as Tabor Research in 2007, the first forecast we put out for complete year 2007 flagged what we called then ultra-scale internet as a segment that we were tracking. By the early 2010s, what was then called hyperscale had grown to where it was really its own segment. We took it out of HPC. Now, because of AI, we've built it back into the total market models, but we've been tracking hyperscale all along. 5 years ago, a little over 5 years ago, September 2019, we wrote a report on the worldwide hyperscale market size. This isn't specific to AI. This is just looking at what a hyperscale companies spend. There's a quote there: none of this is slowing down in the next 5 years. Barring a significant change to the competitive sphere, tier one hyperscale companies will become even more powerful within the forecastable time frame. And that's exactly what has happened. Where we are today, hyperscale companies are now consuming over 3/4 of data center spending worldwide. The hyperscale AI factories get built out gigawatts at a time now, or at least hundreds of megawatts. Technology vendors prioritize their deliveries to go to the hyperscale companies, and that includes your processor companies like Intel, AMD, especially NVIDIA, where GPUs, you have the shortfalls. And this is another area where cloud now becomes an important sandbox for future technology deployment. I can probably get new GPUs faster in cloud and try them for my applications faster than I can get them on premises. So even if I plan to have an on-premises build out, the notion of cloud first doesn't, in this high performance segment, doesn't have to mean I try to do everything in cloud and only do it on premises when it doesn't work. Cloud first in this context can mean everything future looking. I'm going to shop in cloud before I ever commit to anything on premises. Now that's, I don't mean to say that there's full on trend cloud. We were forecasting for a long time that things would get repatriated for cost reasons. In fact, I reported in that article that I saw a great presentation from Geico that they were clawing stuff back on premises out of the cloud, and they were trying to do that in order to manage costs. I'm not going to re-give that whole presentation now. So there is a cost consideration there, but the more uncertain things are, the more it pushes toward cloud. So at the very least, cloud continues to grow along with the market, but I think we could be entering a new era again where the dominance of hyperscale makes things more cost effective in cloud. Certainly the variability provides a big benefit in cloud going forward. And if that becomes the case, then it becomes harder at this point for the traditional server OEMs to continue to compete. Two more quick hits on influence of hyperscales. One thing we've been tracking for a long time is things like programming languages in HPC. And for a long time, I would have been comfortable as an analyst saying, yeah, you get into the HPC sphere, it's going to be 25% C, 25% C++, 25% Fortran, and 25% everything else. And the only thing that ever changed was the composition of everything else. And not that many people were learning Chapel or something else that we saw along the way. It really has been changing now. Now, if I lump together C and C++ and C# and all the other C derivatives, that's still kind of a dominant language. But the number one language across HPC and AI right now is Python. And it's what all the kids are learning these days. You don't get so many people who are learning the other ones. Fortran is falling way back into maintenance mode. And we've also seen a rise in some of the other more hyperscale oriented languages like Go or Julia. Rust is out there. R had a huge spike during the big data revolution and it's still around, and a lot of people learned that. So there's a major influence in languages and how people are programming. AI will continue to influence that, particularly as you have AI coding assistants. And then one that I have to put in here as an effect that is huge on the market right now is talent. We talked to our HPC AI leadership organization, and I'll spend a concluding minute talking about them in a second. And everybody is flagging talent as a major issue that is affecting HPC and AI. Where do we get new talent? How do we keep talent? And a big issue for a lot of HPC and AI users is that hyperscale companies are a major draw. NVIDIA has been hiring like crazy. They're a major draw away from the market. I'm showing the title of a research paper that we did together with Indiana University over the last 2 years, funded by NSF. Indiana University has now published their study. It just came out with the great academic title, Economic Value of HPC Experience for New STEM Professionals, Insights from STEM Hiring Managers. We did the survey portion of that for them, and we'll put out our own version of this that just focuses on our aspects of the study, but we were surveying hiring managers about outside of computer science, in STEM fields outside computer science, about how valuable is HPC knowledge or experience when it comes to a new hire. We found that it did have a quantifiable value, and that new hires coming in could expect better career paths and higher starting salaries if they had HPC knowledge or experience. But that wasn't the only or even necessarily the biggest effect that they could have on their careers compared to some other factors. So we're looking forward to publishing a fuller version of the study that we did together with Indiana University, funded by NSF. But the talent shortage in this market is very real. I made reference quickly to our HPC AI leadership organization, or HALO. I was talking at the beginning about how great I think it is that the Google Cloud Advanced Computing community has this community. This is a similar sort of vibe, but there is a critical difference. This is an end user organization that influences our research going forward. If you're on this call and you're a vendor, we also welcome you to apply. You'll just get rejected. So the application is fine, but we're keeping it strictly end users right now, and that's because when our clients come to us, they want the views of the end user community going through the industry, and the HALO organization is helping us set our research agenda, not just participating in the research, but helping us set the research agenda about what the important topics are for them going forward. This is where our budget data is coming from. This is where you'll see a series of what we're calling state of the HPC AI market reports is going to come out. We've got a press release about that from our side today, going out describing that report series that'll be going through the summer, and I can answer any additional questions about that. No cost to participate. Get access to our research, get best practices study, collaborate with your peers. Please take a look at this and join HALO. And that will conclude my part of the talk. I was hoping to finish by the bottom of the hour, and I've done it. And now, Jay, you and I get to talk and take questions for the rest of the time.
That's right. I've got questions for you first, and then we'll take some from our audience as well. So before we get into questions, I want to make sure that we clarify a few terms for our audience. You had definitions you're using for HPC as opposed to AI, but in that case, you were referring to HPC as a workload class that was the non-AI workload class, right? Large parallel or high throughput, but
it's hard to define HPC strictly as a set of technologies, because then someone comes up with a different technology to run the same engineering application. So HPC to us has always fundamentally been a set of workloads, although what we're really measuring is the technologies that get delivered, technology services that get deployed in addressing those workloads. So we're looking at workloads that are particularly demanding in scale for processing data, I/O. That includes applications in finance like risk management and algorithmic trading, some of the high-end analytics. So it doesn't have to strictly, finance counts as science in that sense. Finance feels a little businessy, but they definitely have high-performance applications.
Right. I want to make sure that our listeners understand that when you say HPC market versus AI market, sometimes in our messaging, we explain that HPC is a methodology for large scale workloads, and that includes simulation workloads, which are the classical HPC workloads, large data analytics workloads, and AI training workloads. And there are simulation workloads that are not HPC. There are AI workloads that are not HPC, like, individual inferences and whatnot. But I just want to make sure that as we go forward in the rest of the conversation, our listeners understand that you're tracking the traditional HPC simulation and analytics market, and also tracking the AI specific market, even if it uses high performance interconnects and parallel file systems and such. You're tracking that as AI workloads.
Yeah, and the primary segmentation for us, the HPC versus AI, doesn't wind up making a lot of sense as a segmentation, right? Because when you get outside of the hyperscale community, what I hopefully established there is that we found that they're largely overlapping, right? And to point out a couple of examples, if I went to Texas Advanced Computing Center, which you mentioned previously, that's clearly part of the HPC market. Are they not part of the AI market? Do they do any AI at TAC? I think they do, right?
Sure.
So do you want
There's
to
going to
count
be,
that?
I think that it's, as your chart showed, there is I think you said 10% that are doing HPC, but not any AI yet, and 11% that are doing AI, I think it was an on-prem chart, but not any HPC. And the vast majority were doing a mix of workloads that included traditional HPC and newer AI workloads. That's great. I want to dig into that a little.
That chart was a year old. When we update that in the next couple of weeks, what you're really going to see is there's almost nobody now doing HPC who's not doing AI. That number is going to be down to 2% from 10. I don't write down the 2% yet. The survey is still going, so it can wiggle. Right? It's going to be more like 2% than 10%.
Yeah, but the point of that really was the huge overlap was people doing both. And people shouldn't look at that chart and think of the demise of simulation applications that require HPC. They should think of it as the rise of AI workloads that are also running on these systems, and the integration in some cases of these workloads to give even more innovation capability, more discovery capability, right?
Yes, in the short term, that's absolutely true, that we haven't really seen a displacement yet of AI replacing HPC. I do think that that is a long-term concern. Well, concern, that's a judgment call. People might see it as a benefit, right? To say, I can do AI instead of HPC. I can get a faster, cheaper answer. And notice I said faster and cheaper. Better certainly could enter into it, but I think that's the way most people are evaluating it. I think AI, the bigger benefit is faster and cheaper. And well, your HPC was a model. How do you know it was right? And the current, I don't know, zeitgeist, if you will, is that people care about getting an answer. And if you start arguing about which answer is right, then you're some know-it-all, right? Like, okay, well, what do you care? It's just science, right? I got an answer, you got an answer. Who says mine is right or yours is right? We both got an answer. That is really the way that the cultural thinking is tracking right now, especially in the United States.
Well, I mean, I could push back on that a lot, but time is short because science wants to get the right answer and business needs to get the right answer. And so there is a question of a good enough answer.
Science wants to get the right answer, and science isn't the one in charge.
Business also wants to get the right answer, at least the one that makes the most money or saves the most money. But I want to dig into a couple of other things that I'm going to take audience questions. One thing that you didn't address in here, and I've seen you talk about it before, is hyperscalers' influence on the chip market. Now, I'm wondering if in the past, you've talked about how they're not only designing their own systems and going straight to the ODMs and bypassing OEMs now, but in some cases, they're designing their own ARM chips, for example, or accelerator chips, for example. My own company being one of those. Other hyperscalers doing the same kinds of things. You didn't mention that in here. Do you not see that as much of a, I won't say threat, but impact on the HPC market as you did, or is it just because you were compressed for time? But you do,
yeah,
I think you still see
compressed for time
there, especially because of precision levels and AI driving the need for lesser precision levels, for example.
Yeah, absolutely. So to the extent that AI is driving the market and hyperscale is driving AI, and hyperscale is where all the volume is, when the vendors prioritize the hyperscale AI market, and that's where we can call it more pure AI, right? Because when you talk about the hyperscale AI market, that really is a pure AI market. They're doing AI for the reasons hyperscale companies do it, right? And that is driving toward lower precision, and we see lower precision getting emphasized now in vendor roadmaps. Before 2 months ago, I had never heard the phrase Ozaki scheme. And then over the course of 3 weeks, I saw 3 presentations on it. And for those others who haven't seen a presentation on it yet, this is an innovation that's coming out of Recon that is the leading contender for how to emulate 64-bit performance using lower precision, like int8, for example, slicing up matrices and doing. There's some workloads where it works well, and there are other workloads where it doesn't work well. And for those where it doesn't work well, the answer might be too bad, so sad. You know, but then we've been here before. When we looked at when the industry started migrating toward clusters away from SMPs, what was the dialogue of the time? Well, that's not really HPC. It's good for flops and the top 500 list, but it won't really serve real workloads. And it's capacity, it's not capability. IDC had a whole split in their market about capability computing versus capacity computing. And it took 8 or 10 years, but clusters eventually became the dominant architecture. You had to go through the pain of putting everything in MPI once, but then you had done it. And there were still passionate HPCers with their backs to the wall saying, you're going to trash your efficiency and your efficiency is going to fall to the single digits. Well, that's exactly what happened, but it was cheaper. So we went that way. And, we're going to see a lot of that with regard to the effect of hyperscale and AI. And one last thing I'll say about that is one of my 5 big questions was, can anyone challenge NVIDIA? And, they're the traditional competitors, your Intels and AMDs. I think NVIDIA has gone beyond that. There are your new startups, whether it's anyone from a Next Silicon on the CPU side to your Graph Cores and Samba Novas and Groks. And I always hate listing them because then I wind up leaving out somebody obvious. Okay, but I mean that category of company. None of those is Cerebras, I should have mentioned. None of them is big enough to really put a dent in NVIDIA right now. The real competitive dynamic by the end of this decade is going to be NVIDIA versus the hyperscalers' own processors that you just mentioned.
Exactly where I was about to ask you.
That's the competitive dynamic that's set up for 2030, because NVIDIA is also becoming its own cloud.
That's right. NVIDIA is becoming its own cloud, but they're also currently partnering so that cloud providers can host versions of their cloud. But many of the cloud providers and hyperscalers are developing their own AI-specific chips. Again, Google being one of them, but not the only one. And only the hyperscalers currently have the best view of how their AI-specific chips stack up against NVIDIA in terms of performance, price performance, et cetera. But the reality is, for an internal usage, the price performance thing is a very different number, right? So using your own training chips to train your own software that you didn't have to buy from somebody else does change those price dynamics relative to a customer accessing them as well. So certainly these hyperscalers, just as they've made this migration to integrating ARM heavily into hyperscale deployments, have an opportunity to do this with their AI silicon too, right?
That's right. And the advice I would give to Google right now is that you view NVIDIA as a necessary partner for now, but an obvious competitor for the future. So you better get onto a different square quick.
Well, on that note, I'm going to start taking public questions.
Because you're not going to comment on that one bit.
Well, they're a great partner of ours, and we make great AI silicon.
Oh,
so
of course they are.
Let's go with Bill Magro. He is the CTO and head of HPC at Google Cloud. Bill asks, I believe you said cloud is reaching an asymptote in HPC. Can you expand on this? In particular, how do the trends differ across the industries and across size of institution or size of system?
Yeah, thanks, Bill. Cloud had been reaching an asymptote in growth according to our most recent forecast. I think the new forecast, when it comes out, is going to break that asymptote and it'll go into higher growth again. I will say that we were projecting a higher percentage of cloud as part of an overall HPC AI budget compared to other analysts who measure this space. We had it up in the mid-20s, around 26% or so of an HPC AI budget goes to cloud on average. But then it was kind of flattening out there. Now I think it'll start to grow again, but wait for the new forecast for that to come out. How is it different by segment? It's highest in commercial. It's higher in commercial than in public sector, and it's higher in low budgets than it is in large budgets. So you'll you'll see a much higher penetration of cloud in a smaller commercial HPC AI deployment than you will at, say, a large government or academic research lab. And if you go to Oak Ridge National Labs or Texas Advanced Computing Center, it's their job to be a cloud, not to use a cloud, right? So that's where that part of the budget knocks down the average. The influence of enterprise AI looking forward will certainly continue to influence that, and I think is part of what unlocks that asymptote going forward.
So I got two questions for you to follow up on that and drill down into where I think Bill was going with that. One, what is changing from your asymptote to become an increase again overall, irrespective of domain or vertical or scale or whatnot? Why do you project the net is going to rise again? The first one, you said it really took off during COVID. What is your overall meta factors for why it's going to grow again? And second, within those groups, you just mentioned that, for example, not as much for public sector as private sector. But earlier in your talk, you mentioned there's a growing number of silicon options and software options and such. And so cloud gives you the ability to try more things than a singular on-prem deployment. So do you see the potential for cloud growth even in those public sector institutions whose primary job is to be their own cloud with their own on-prem system served to others, also embracing cloud as a way to provide different silicon, especially in uncertain federal funding times, faster than they could in the past, depending solely on federal funding?
Those two things are related, right?
Yeah.
So it's hard for me to answer one then the other. The primary thing that helps cloud is uncertainty, right? And if you're uncertain about your budget, if you're uncertain about your workloads, so the fact that you have more different technologies serving more different workloads already pushes things towards cloud across all segments. Now, with regard to public sector funding, especially in the US right now, this is a tricky one because we're talking about what we think the effects of the US administration will be, regardless of having any political preference or who you should or shouldn't vote for. But this is an unconventional administration. It is essentially an anti-government government. And I think everyone would agree on that on both sides, right? The whole point is to reduce government spending. The primary advisor, who's the head of the DOGE, of the Department of Government Efficiency, is a big AI guy, right? And believes in that. But we're trying to get rid of public sector spending. And in many cases, that'll get replaced by private sector spending. So, for example, would it be realistic to project that this administration could say, you know, an organization like NASA or NOAA, we don't really need that. We're going to get rid of the organization entirely and replace it with public cloud and AI, right? And that is a predictable thing that could happen over the course of the next couple of years, that NOAA, the government gets out of weather forecasting entirely, and it becomes a contract to a cloud company to do it with their AI instead. There's a little bit of a question of, you know, if you got rid of NOAA and replaced it with a contract to XAI, or got rid of NASA and replaced it with SpaceX, is there any conflict of interest involved in that? That's a separate question, okay? But regardless, the conversation is live, right? That is a realistic conversation that's going on right now.
All right, let's take another question from the audience. Rick Friedman asks, great to hear your talk. What do you see as the potential limiting factors on how the market evolves and AI continues to grow?
Well, so for consumer AI, and most of it is consumer still, we're still groping for the ceiling, right? You know, how big can Meta is another one I like going to here because it's a little cleaner. They're not selling it as a cloud service. And if Meta spends $30 billion a year on AI, and I think it's actually north of that, but let's keep it at 30 billion for right now. All right, tens of billions of dollars being spent by individual companies. Tens of billions. You're used to thinking of hundreds of millions as being a large supercomputer. This is 100 times that, 2 orders of magnitude in annual spending from single companies. People still haven't really grasped how big this is yet, right? And you know, the DOE is used to thinking of themselves as leading the market. They're not. This is not even close in levels of scale right now. There was a different analyst put it out, how long before we see a hyperscale system as #1 on the top 500. Like, that would have happened a long time ago if anyone wanted to. They just could. It's not close. The hyperscale systems are way bigger. So back to Meta, if they spend $30 billion a year, how does that make sense? Well, they also have 3 billion unique users worldwide across all their platforms. So the question for Meta becomes, can I monetize that AI investment to the tune of $10 per user per year, more revenue per user because of AI? Can they do that? They can. I think they can make $10 more per user per year on AI, but that's a consumer market. Enterprise AI, which everyone is talking about, I think is still much smaller. And it's not that it doesn't exist, right? Of course it exists. Everyone's going to run to it. But when you talk about enterprise computing investment and the ROI implied there, there's 2 ways for an enterprise to make it profitable. One is I can make more revenue. The other is I can reduce my costs. That's kind of the 2 ways to make something profitable. Most of the discussion so far has been on reducing costs because I'm going to increase efficiency or reduce my head count. And there's a limit to how much of that you can do. Even if you annualize the spending, how much money will you spend to save $1 million a year? It's kind of got a cap on it. And you can't repeat the trick and do it again and again and again. And then the upside on revenue is kind of limited. It's more like this is the new cost of doing business, like going to web, right? Where everyone does it. People still have the same market share they had before, but you're spending money this way now. And anyone who doesn't gets burned, right? This is where Barnes and Noble didn't react fast enough to the new way of doing business and got crushed by Amazon, right? They could have, but they didn't, and so they had a displacement.
Okay.
But at the top, did people read more books because the web was there? That's dubious.
All right, next question is from Troy Trimble. What signals have you seen around the desire for sovereign deployments of AI/HPC hardware? Thoughts on how that has impacted your forecasts or not?
Absolutely affected the forecast. Sovereignty is a top issue worldwide. And what we see are their dominant notions around American sovereignty, EU sovereignty, Chinese sovereignty, and then you get into Japanese and UK. India has their own initiatives. And then where do you stand if you're Australia or Canada and you're used to having your own national HPC AI infrastructure? How do you even compete? Or is all of that going into somebody else's hands? So in the short term, it has the potential to increase spending because every independent nation has to say, how do I secure my independence? In the long term, that kind of isolation tends to dampen long-term growth rates. So it's kind of a short-term, long-term thing, and you have to look at each country or region in the case of EU independently. So I appreciate the question, and yes, it has an influence in our forecast.
All right, we have a question from Chris Browning. It says, where do you put OpenAI, Anthropic, xAI, and things like Stargate? These aren't necessarily traditional hyperscalers, but are large and influential for AI. How do you gauge their influence versus the hyperscalers? So I guess one of the questions is there, are you grouping them with hyperscalers, or are you treating them differently?
They are grouped as hyperscalers,
right,
and they're in our hyperscale AI segment. They're kind of next tier down, but then it gets tricky because then you look at our OpenAI. They're huge. They're a major influencer. Do they have any of their own infrastructure, or are they using stuff on Azure? Right? It's mostly they're influencing on the model building side. And part of our research calendar for this year that we've announced is that we're going to do more segmentation on the hyperscale AI part of the market, and not, first of all, tier 1, tier 2, tier 3, and where does that go? But then model users versus model builders, who has their own infrastructure, who uses somebody else's, and then can we carve up things like machine learning, agentic, generative, that stuff changes so fast and
Mhm.
tends to be on the same infrastructure that's more on the notion of trends than market size, because it's hard to look at, well, this is a computer that does generative AI. Well, wait, now it's a computer that does agentic AI. Now it's doing cognitive AI, right? And it's the same infrastructure. So how do you count it?
Well, I mean, the same CPU-based HPC systems did different workloads all the time, so I'm not surprised that the names of the AI-specific workloads
Yeah.
would change and whatnot. But right. Okay, so Adnan Khalil says, "Hi Addison, great to see you here. To the point of
I had none.
hyperscaler silicon being the main competition to NVIDIA, how do you think a leapfrog play in AI might be? It seems like NVIDIA is also very strongly positioned even for inference." So I think his question is there, how do you think hyperscalers might achieve leadership in silicon?
I think leadership in silicon is going to come secondary to leadership in data possession. The fight for the last 15 years has been about possession of data, which is different from ownership of data. Whoever controls the data is going to control it in the long run, which is why NVIDIA is actually at a disadvantage relative to the other cloud companies. They don't actually hold much of their own data at this point. They need to build their own clouds and do it quickly in AI if they're going to compete. And then if I own the data on my cloud, then people will use whatever processors I'm offering. And that's just the way that goes. It's a matter of getting people's data inside of your clouds. Now, as far as a leapfrog play goes, if you're talking about being one of the smaller companies that's coming in silicon and how do you establish yourselves, most of these companies are not going to succeed. The ones that do will most likely do it through acquisition. For example, look back at the whole sphere of Twitter, X, XAI, whatever. This group of companies, if you will, that all have the same common owner, that was a big mover last year in terms of coming up and being a tier one hyperscale. That was a big push where they moved into spending that tens of billions of dollars a year, where Twitter hadn't been doing that previously, and now it is. Twitter also doesn't have, I'm going to call it Twitter out of convenience, but you know what I mean. Twitter also doesn't have its own processor that it has been working on, at least not publicly known. Is that ripe for an acquisition? Right? Would Elon Musk go and buy a company like Cerebras in order to get the inference capability within his company and get into that game? That's the kind of thing we would look for in terms of market dynamic. And if that company would do it, would another company do it? And I don't mean to promote Cerebras over Grok or Shenbun over anybody, right? I just picked one so we could have a conversation because it's easy to have a sentence there. But I think those companies would be looking at, is there another hyperscale? What's Oracle going to do? Is Oracle going to move up and be in that tier? If so, do they need a similar acquisition? That's what we would look for.
Yeah, I think there are really two primary ways of taking some kind of silicon leadership. If you're offering it as open infrastructure, and you've got to give tremendous performance or price performance benefits, and for an established market, have a software ecosystem that enables relatively straightforward migration to yours. So if you don't offer a big advantage and you don't offer an easy migration path on your open infrastructure, your cloud offering to everybody else, it's going to be very difficult to have your own silicon or someone else's silicon that you acquire achieve a huge market share that way. If you do it behind the scenes, if you're offering software as a service, that's AI powered software as a service, nobody knows technically what processor it was trained on anyway. So then the question is, how big is your software as a service? How much consumer and or enterprise revenue are you generating to justify the ongoing investments and the ability to keep up with the current silicon leaders in deploying that infrastructure? And I assume you talk to all of the hyperscalers. I talked to one. I assume that many of them are projecting performance characteristics and internal price performance characteristics that are advantageous for themselves and significant enough revenue over the course of multiple generations of that silicon that they're going to save money while offering powerful AI services to consumers and enterprise on their own silicon. So that's got to be the belief, right? You don't invest in a competitive piece of silicon unless your belief is that the business case is there. And I suspect it's probably stronger for hyperscalers currently, and I'm using this term very generally, on the internal side than the external open infrastructure side.
I think that's a reasonable hypothesis, Jay, and it's not one that I really ought to get into commenting on, because then it starts to sound like I'm speaking for other companies' strategies. But I would say that's a reasonable way to look at the market. What I would do is look at what the implication of that is across the rest of the market worldwide, because if you're the Department of Energy or someone else that looks at science, and more of this is going to be driven by hyperscale right now, just understand that the AI that's needed by the AI applications that a hyperscale company invests in are going to be different than AI for science, right? Now they're related, and I think you can use the one to get to the other, but the agenda for HPC and science right now is being driven by something else.
All right.
And HPC has always been at the wag end of a larger market with enterprise computing, but now AI is bigger than HPC is and is driving in a different direction.
All right, I got one final question for you, and it's about your final slide. Deepak Suresh asks, he says, thank you, Mr. Snell, for the great and insightful presentation in our community today. He says, I have a question on HPC skill expectation. What is the HPC skill expected the most from Halo?
From our HPC AI leadership organization, you don't need any particular skill. You need to be on the user side rather than on the vendor side. But then other than that, we invite you to be part of the conversation. We really want, it's not like it's for sysadmins or programmers or lab directors, right? We want all of them in there. And then you'll find conversations that are suitable for you. And it's not just surveys here. We're building a whole members area of the website that will offer resources and videos and everything else. We will have Halo only, member only events. We are not intentionally at this point building out our own event series. We plan to leverage events. We don't think we need more stuff on our calendars is what it comes down to. But when we're at events that we have in common, like SC or ISC or SC Asia, which I was just at this great conference. Go to SC Asia, people. It's awesome. That's a good conference series. Next up, Osaka in January 2026. When we're at conferences like these, we'll try to put together Halo activities that are based on that. And then if our advisory committees tell us, no, hey, we got to have an event, all right, then we'll facilitate it. But until our user advisory committees tell us they want an event, that's not what the point is.